Okay, good morning everyone. So today we are going to discuss about multiplexer, demultiplexer as well as decoder. So in our last class we have discussed about what? Half adder, full adder, at the same time parallel adder, serial adder, ones complement, two's complement adder, subtractor. Okay, so before going to discussed about today's class, once I would like to revise last class topics. So what is our last class topic? Half adder. So what is the use of half adder? It is a device or it is an arithmetic circuit which is used to add two bits at the same time, two single bits. And while coming to the full adder, it is a device which is used to add three single bits at the same time. But while coming to the parallel adder, it is an arithmetic circuit which is used to add multiple number of bits at the same time. So while coming to the word multiple, it is used to add two bytes at the same time, or also it is used to add two nibbles at the same time, or six multiple bits at the same time. Okay, and next, while coming to the serial adder, it is also used to add multiple bits at the same time. But why we are moving with parallel adder, why we are designing serial, both are used to add multiple bits only, na? So why means what? Here in the parallel adder, more number of full adders are used to. So that means in each stage, to add three bits at the same time, one full adder required. So like that, if n number of bits are added, so n number of full adders are required. So in this way, it is used to add multiple number of bits at the same time with high speed but with high cost, and also circuit becomes complex. In serial adder, there is a need of recording carry. For that purpose, it requires memory element. But the speed of operation is low. Why? Because it will add multiple bits, but not at the same time. Bit by bit, it will add. Next, while coming to the two's complement adder subtractor. So here, two's complement adder subtractor is used to add or subtract multiple bits at the same time. So what is meant by multiple bits? What is meant by two's complement? Why it is called two's complement means here addition is normal addition, like three multiple bits added at the same time with help of full adder. But the circuit also consisting of exclusive OR gates. With help of these OR gates, here the subtraction is also done. Okay, so these are our last class topics. Okay, now I would like to discuss about next topic, that is multiplexer. So already I told you in our first combinational logic circuit definition is already over. What is meant by multiplex? It will multiplex, it will add it more number of inputs together and produce single output. This is general meaning. But while coming to the original digital electronics meaning, it will select binary information from many of input lines and direct it to a single output line. Okay, it will select the binary information from one of many input lines. Example, if once you have a look about the symbol, so this is the symbol of diagram. So this multiplexer is called 4 by 1 multiplexer. These are the inputs, D0 up to D3. D1 is there, also D2 is there, and this is the output line Y. So see here. So now it will select the binary information from one of many input lines. So one of many means here D0 to D3 four lines are there, but output is only one, whether it may be selects D0 or D1 or D2 or D3. So simply it will select the data among the particular line. So that's why it is also called data selector. And here one question is there, how it will select the data, based on which factor it will select the data. So for that purpose, each and every multiplexer having some selecting lines, so these are indicated with S. So here we are using two selecting lines. And here more one doubt we are getting, why two selecting lines are only required to select four data? So here one logic is there. So what is that formula? So here 2 to the power of n is equal to number of inputs. 2 to the power of n is equal to number of inputs. So here 2 to the power of n is equal to, we know how many number of inputs are there, combinations, 4 combinations are there. So that n is equal to how much? 2. So here n is equal to what? Number of selecting lines. So n is equal to what? Number of selecting lines. So in this way, it consisting of 2 selecting lines and 4 data lines. 2 selecting lines and 4 data lines. Okay, that's why it is called data selector. Okay, it will select the binary information from many of input lines and direct to single output line. That's why it is called what? Data selector. Okay, and this data selection is controlled with help of what? Two particular input lines. Those lines are called data selecting lines. Okay, this is about multiplexer. So here the number of selection lines is equal to whom in formula? 2 to the power of n is equal to number of input lines. 2 to the power of n is equal to number of input lines. So here n is equal to what? N is equal to what? Number of input lines. N is equal to number of selecting lines. So these are the selecting lines. So 2 to the power of n is equal to 4 here. If we substituting n is equal to 2 only, we are getting 4. So that selecting lines are is equal to 2. Okay, so this is the block diagram or simple symbol of our 4 by 1 multiplexer. So in diagram, how many number of inputs are there? 4 inputs are there. Okay, and how many number of selecting lines are there? 2 selecting lines are there. Okay, with help of 2 selecting lines, here we are selecting 4 input lines, one by one at the same time. Means simply the 4 by 1 multiplexer will select one input among the 4 inputs at the same time. Means at a time it will select only one input among the 4 inputs. For example, see here, if it consisting of D0, D1, D2, D3, so one time it will select D0. So how it will select D0? See here, depends upon selecting lines. If S0 and S1 both are 0, 0, then it will select the data line D0. If these are 0 and 1, it will select D1. If these are 1 and 0, it will select D2. If these are 1 and 1, it will select the bit D3. So in this way, depends upon the selection lines. Whatever the signal that is applied to the selection lines, the multiplexer will select one of the 4 input lines, whether it may be D0 or it may be D1 or it may be D2 or it may be D3. Okay, and here in the symbol one more signal is there, that is enabling. So what is the need of enable signal? So only the application of enable signal, if the circuit having enable signal, only the application of enable signal only the output must be produced, present output must be produced. If enable signal is not applied, if enable signal is equal to 0, so the output will not change even though the inputs are present and selection lines are present. So this is the theme of what? Enable signal. Means what? The enable signal will now control the entire 4 by 1 multiplexer. If the enable signal presents, only the input must be changed according to the selecting lines. Okay, so how it will change? So once see here, this is the circuit diagram of our 4 to 1 multiplexer. So see here in our circuit, it consisting of 2 NOT gates and 4 AND gates, 1 OR gate. So in 2 NOT gates, S0 and S1 are applied. Why here we are taking the help of NOT gate? Means S0 is 0, 0, 1s, but sometimes it is also 1. How we are taking 1? So simply this 0 is inverted here and we are accepting. If we are taking from this, it is like 0 and 0. But if after passing it through the NOT gate, we are getting 1. Means if we are requiring 1, the S0 is applied to NOT gate, then it is taken to the AND gate input. If we are having only 0, it is directly connected to the AND gates. So in this way, here we are using 2 NOT gates for the sake of converting S0 and S1 into 0 to 1. Okay. So this is the circuit diagram. How can we design this circuit means depends upon the logic. Okay. So now you are moving to see the truth table. So once see the truth table. So this is the truth table, already I explained. So see here, already I told that here without enable signal, so okay, here enable signal is considered as X. Without enable signal, the output should be always is equal to 0. So after application of enable signal, the output must be changed. Okay. So next, while moving to the Boolean function. So here, how many number of input variables are there? See here, 4 by 1 multiplexer means 2 to the power of n is equal to 4. Here n is equal to 2. So here we are getting how many number of outputs? 4 outputs. But even though we are taking n is equal to 2, we are getting less than. So we are also write like this. That means what? With help of two selection lines, sometimes we also may get 3 outputs only, 2 outputs only. So in that way also there is a possibility of designing the circuits. Okay, in that way also. See here, while coming to the one example, so simply the multiplexer will give the sum of the product function, that sigma function. Okay, for example, if it consisting of 3 inputs A, B, C, okay, one is enable line and 2 are inputs lines. If we are going to select 1, 3, 5, 6, so total how many number of bits are there? 4 bits. One time 1 will be selected, next time 3 will be selected, next time 5 will be selected, next time 6 will be selected. And see here, for that purpose, the circuit is like this. Okay, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, and 1, 1, 1. So in this way, here we are going to applying 3 inputs at the same time, and the 4 outputs will be selected. 4 outputs will be selected. Okay. See here next, while coming to the next one, and this is the circuit of our previous function 1, 3, 5, 6. Likewise same, but here we are developing AB. So C, 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 C bar means, so these are the inputs of, these are the selection lines AB. So these are the 1, 3, 5, 6. 1, 3, 5, 6. Is it clear? Or simply the AB here we are applying, and 0 C, 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 C bar. So that means what? So 0, 0, C will be selected. And if the inputs are 0 and 1, if the inputs are 0 and 1, this C will be selected. Next, if the inputs AB are 1 and 0, C will be selected. If AB are 1 and 1, C bar is selected. So this is the diagram of simple multiplexer, 4 by 1 simple multiplexer. 4 inputs are there and 1 output is there. So in this way simply we are selecting the circuits. Okay. And while coming to the next topic, so our next topic is what? Demultiplexer. Demultiplexer. So the name itself indicates that demultiplexer means this is the opposite function of multiplexer. Here the multiplexer will combine the inputs and produce single outputs. But here in demultiplexer, it consisting of single input and 4 output lines are there. Single input and 4 output lines are there. This input must be transferred over one of 4 lines. Okay, for example, if I would like to give the selection lines are 0 and 0. So this 0 must be transferred over the line D0. If this the input is 0 and 1 selection lines are, this bit is transferred over D1 line. Next 1 0, D2, 1 1, D3 means our input is transferred over the one of 4 lines in 4 by 1 demultiplexer. Okay, simply the demultiplexer will do the function of decoder. So simply the demultiplexer will do the function of decoder. So the decoder is a device which is used to do the function of demultiplexer. So how can we design the demultiplexer? Means with an enable input signal. With an enable input signal, the demultiplexer will be designed. So to whom we apply the enable signal? For decoder. Okay. So now we are going to see the diagram, block diagram of demultiplexer. So see, this is the block diagram. So here, how many number of input lines are there? Only one. In multiplexer, one output is there. In demultiplexer, one input is there. Okay. So this one input is transferred over D0, D1, D2, D3. So how can this input must be transferred over the signal? With help of two selecting lines S0 and S1. Okay, and see, these two lines are data selection lines, and this is called enable line or data input line, and these are called data output lines D0, D1, D2, D3. And the name of the circuit is called 1/4 multiplexer. Why it is called 1/4 multiplexer? Only one input is there and four outputs are there. That's why it is called 1/4. And these data must be transferred over one of these four output lines, depends upon the input applied to the selection lines. Is it clear? So this is the block diagram of our 1/4 demultiplexer. Okay, how many number of lines are there here? Two lines are there to select the data. So how many number of inputs are applied in demultiplexer? Only one input is there. How many number of output lines are there? Four lines are there. Okay, so in this way the data must be selected. Is it clear? The name of the circuit is called 1/4 demultiplexer. One input must be transferred over the four lines with help of two selection lines S0 as well as S1. Is it clear? So this is about the diagram of the multiplexer. Okay. So next, this is the truth table. So if S is equal to 0, S1 is equal to 0, whatever the bit selected, that is called what? D0. If S is equal to S1 is equal to 0 and S2 is equal to 1, it will select the bit D1. If S1 is equal to 1, S2 is equal to 0, the bit D2 is selected. If both are 1, S1 is 1, S2 is 1, the bit D3 is selected. So in this way, the output must be selected. At a time only the one output line is enabled and the remaining are in disabled condition. Okay, see here, to construct the circuit, here we are moving with AND gates also. So this is the existence of decoder. Means why the decoder is used means, so to select a particular symbol, particular line, the decoder circuit is used. Here also like the same logic is used in multiplexer. Next, see here, while coming to the decoder. So our next topic is what? Decoder. So in decoder circuit, okay, the name itself indicates it will decode something. It will decode, coding. It will converting code language. We in our daily life we listen about coding, decoding. Okay, one form of binary or other number systems into the some other form. So here our decoder will transfer other number systems into the binary number systems. Other numbers into the binary number system. Other numbers are what? Whether it may be the hexadecimal number, or it may be decimal number, or it may be octal number system. Into which system? Into binary number system. So that is the main theme of decoder. That is meant by decoder. So it is a device which is used to convert any of the number system, that may be either octal number system, or it may be hexadecimal number system, or it may be decimal number system, into binary number system. So here it must be indicated with n to 2 to the power of n to 2 to the power of n decoder. Means here n are the input lines and 2 to the power of n are the output lines. Okay, for example, if it containing 4 output lines, so here how many number of input lines are there? 2 only. So here n indicate what's not selecting lines, input lines. In previous case, in multiplexer and demultiplexer, n indicate what's only the number of inputs, but here indicates what? Number of inputs, not selecting lines. Okay, but here the inputs are indicated with S1 as well as S0 only. Okay, see the symbol. Okay, this is the symbol of decoder. How many number of input lines are there here? 2 input lines are there. Those are S0 and S1. How many number of output lines are there? 4 lines are there. 1, see, Q0, Q1, Q2, Q3. So these are the output lines. And how many number of input lines are there? 2 input lines are there. 2 input lines are there, S0, S1. And 4 output lines are there, Q0, Q1, Q2, Q3. Okay, 2 input lines are there, 4 output lines are there. Okay, and once see, so these 2 input lines, the data on these 2 input lines must be transferred to the single output lines at the same time. Single output line. So how means one step? For example, if S0 is equal to 0 and 0, the data must be transferred to which line? Q0. If these are 0 and 1, it is transferred to Q1. Okay, if it is 1 and 0, the data must be transferred to Q2. If these are 1 and 1, the data must be transferred to Q3. Okay, if both are 0, 0, the data must be transferred to Q0. If these are 0 and 1, the data must be transferred to Q1. If these are 1 and 0, the data must be transferred to Q2. These are 1 and 1, the data must be transferred to Q3. In this way, the data must be transferred to the different lines. Okay, and see here, while coming to the diagram, here it is the truth table. So what is meant by truth table? Already I said, if any table will relate the inputs and outputs, then the name of the table is called truth table. So whatever I explained, so it is there 0, 0. Only the output means transferred to Q0 line, it is enabled and the remaining are disabled. If these are 0 and 1, only the Q1 is enabled, Q0, Q2, Q3 are disabled. If S1 is equal to 1, S0 is equal to 0, Q2 is only enabled and the remaining Q3, Q1, Q0 are in disabled condition. And if both are high, Q3 only enabled and the remaining are in disabled condition. Okay, so in this way, if it is a 2 by 4 decoder, 4 combinations occur. If it is a 3 by 8 decoder, 3 selection lines are there and 8 output lines are there. At a time, of course, 8 output lines are there. At a time, only one line will be activated. Is it clear? Okay, so this is with help of enable signal. Okay, this is the circuit diagram. So see here, it also consisting of 4 AND gates and 2 NOT gates for selecting the selection lines. If the selection lines are applied directly to the gates, means 0, 0 without accepting the NOT gates. If S0 is 1, then it must be complemented with help of NOT gate, and it is given to the AND gates. Okay, if we want 1, then it must be complemented with help of NOT gate. How many number of gates are used here? AND gates. 4 AND gates are used here to develop the logic. So this is the truth table. Okay, and see here also in decoder it consisting means without enable signal also we design, but here with help of one more line we design the circuits. The name of that line is called enable. What is the name of that special input? Enable. So then what is the use of enable signal? If we apply the enable signal, if enable signal is present after application of high level signal to the enable only, the output must be changed according to the input. If enable signal is not present, means it is in disabled condition, deactivated condition, the output is not changed even though the inputs are changed. Inputs change aina sare, even though the inputs are changed, the output may not changed. Okay, so that is the main use of enable signal. So in enable signal, by application of enable signal only, the output is changed after the application of input only. After the application of input only, the output will be changed. If enable signal is not there, even though the inputs are present, the output is not changed. Once see here, enable is equal to 1, it will activate the decoder. So it behaves like a decoder and it will produce the output. If enable is equal to 0, it will deactivate the circuit and the outputs are 0 even though the inputs are present. See, this is the truth table. Okay, once observe the truth table. So what we observe in the truth table? See, first 4 lines enable is 0, 0, 0, 0. So in first case, if enable is 0, both selecting lines are 0, no output is produced. But in second case, enable is 0, S0 is 1 also, no output is there. In third case, if enable is 0, S1 is 1 also, no output is produced again. In fourth case, enable is 0, both inputs are high, also no output is produced. Both inputs are high, also no output is produced. Okay, and while coming to the next one, if enable is equal to 1, if enable is equal to 1, both are 0, 0, 0, 1, 1, 0, 1, 1. If enable is equal to 1, for the first case, the output must be transferred through the bit Q0. If enable is equal to 1, if 0 and 1 selecting lines, Q1 is high, Q1 is high. If enable is equal to 1 and 1, Q2 is high. If enable is equal to 1, both selecting lines are 1 and 1, then the output bit Q3 is selected. In this way, if enable is not there, even though inputs are present, the output is not produced on any line. If enable is there, according to the selecting lines, the output must be produced with help of one among 4 lines in 2x4 decoder. Is it clear? Okay, see here. Next one, without enable signal. Again here the circuit is there. With enable, the circuit is there. Okay, so with enable the output is changed. Without enable the output is not changed. And see here, so this is the block diagram of 2x4 decoder. Okay, this is the block diagram. One with help of enable signal is 0 and with help of enable signal is 1. With help of enable signal is 0, no output is produced. with the help of enable signal, output is produced. So here in the logical expression, S0 and S1 is considered with help of bar. Means if S1 and S0 are 0, 0, in mathematical expression, it is written as bar. Okay, if it is 0 and 1, S1 is not complemented but S0 is bar. If it is 1 and 1, no bars are there in expression. One see here. So here in first case, S1 and S0 both are having complements. In second case, only S0 having complement. In third case, S1 having. In fourth case, no one having. So if it is having complement means that is equal to 0 logically. But in mathematical expression, it is having bar. So in last case, no bar is there. In last case, no bar is there. That means what? No bar is there means in mathematical expression no bar means in logical expression S1 is equal to 0 and also S0 is equal to 0. Is it clear? Okay. So these are the logic symbols if enable is 0 once and if enable is 1 once. Okay. So now it is 3 to 8 decoder. So till now we are seeing what decoder? 2 by 8. So now it is 3 by 8 decoder. Okay. Okay, let's see. In 3 by 8 decoder, how many number of input lines are there? 3 input lines are there. How many number of output lines are there? Once check. Q0 to Q7. 8 output lines are there. So how can we select already? I said the logic. So 2 to the power of n is equal to number of input lines. See, I write the logic. So noted. How we are getting 8? 2 to the power of n is equal to 8. Here n is equal to number of input lines. So by replacing n is equal to 3, we are getting how much? 8. We are getting 8. 2 to the power of 3 is equal to how much? 8 we are getting here. Okay. So here how many number of input lines are there? So 3, S0, S1, S2. How many number of output lines? So why? Because it is a 3 to 8 decoder. 3 input lines are there, 8 output lines. How can we represent the outputs? Q0, Q1, Q2, Q3, Q4, Q5, Q6, Q7. So in this way, we select the 8 among the means the input is transferred over these 8 lines. Okay. Once observe the truth table. This is a truth table. Okay, while coming to the truth table, for the first stage, 0, 0, 0 means both S0 is 0, S1 is 0, S2 is 0. The bit Q0 is selected. Which bit is selected? Bit Q0 is selected. In second combination, 0, 0, 1, the next bit Q1 is selected. Is it clear? And while coming to the third stage, in case 3, S2 is 0, S1 is 1 and S0 is 0. For this combination, bit Q2 is selected. In your competitive examinations, the questions are like this. In decoder, when the bit Q4 is selected, it's very, very important remembrance of truth table is. Okay, so that I explain like this. So next, if S2 is 0, S1 is 1, S0 is 1, the bit Q3 is selected. The bit Q3 is selected. And next, if S2 is 1 and S1 is 0, S0 is 0, the bit Q4 is selected. Bit Q4. Next, S2 is 1, S0 is 1, the bit Q5 is selected. And if S2 is 1, S1 is 1, bit Q6 is selected and both are high. S0 is 1, S1 is 1, S2 is 1. If both are high, the bit Q7 is selected. So in this way it will select the output lines. Okay, according to the inputs the outputs will be selected. According to the inputs the output will be selected. That means the input must be passed through one of 7 lines. Okay, now according to the truth table we can develop the logical expression. Okay, logical expression means it is represented with S0, S1, S2. So where we are getting zeros, for that we are applying complement or bar. See, S0 is equal to 0, S1 is equal to 0, S2 is equal to 0. Now I am putting complements S0 bar, S1 bar, S2 bar place. Next one is what logic? Q1. S2 is bar, S1 is bar. Why? Because 0, 0, 1. Next Q2. 0, 1, 0. So that S2 bar, S1, S0 bar. 0, 1, 0. Next for Q3. See here. Here it is Q3. Okay. S2 bar. That means 0, 1, 0. Next S2, S1 only bar 1, 0, 0. Next Q5 1, 0, 1. So that only S1 having bar, S2, S0 no bars. Next in Q6 S2, S1 no bars, cause of that S2 is equal to 1, S1 is equal to 1, S0 having bar. Next one in Q7 all are high. S2 is equal to 1, S1 is equal to 1, S0 is equal to 1. So no bars are there. Is it clear? Okay, so this is the truth table of decoder and these are the logical expression symbols S0, S1, S2 logical expression symbols. Okay, this is about our decoder. Once see here some multiple choice questions are there. Decoder is opposite function of multiplexer, demultiplexer, encoder, none of these end. Okay, next decoder circuit of two input lines gives outputs. Two outputs are 4 or 8 or 1. Here once again I would like to repeat the question. Decoder circuit of two input lines. You develop the logic first here. 2 to the power of n is equal to number of output lines. Na? According to that logic, here n is equal to how much? They giving 2. So 2 to the power of 2 is equal to how many number of output lines we are getting? 4. So what is our answer? 4. Is it 4? And see, it is 4. Okay. Next, third one. Decoder is used to convert binary to octal, BCD to decimal, hexadecimal to binary, all the above. Hexadecimal to binary. Okay. Next, see here the circuit that selects one of the 8 input lines. One you write like this, yeah, then we are getting easily. One of the 8 is called 1 by 8. 8 output lines are there. One of the, once again you read, one of the 8 inputs. How many number of inputs are there here? 8 inputs are there. Among 8 it will select how much? Only 1. So that's why it is called what? Looking like it is a 8 by 1 multiplexer. So once see the possible combinations. So what is our answer? 8 by 1 multiplexer. What is our answer? 8 by 1 multiplexer. Is it clear? Okay. Next one. Okay. See here, next multiple choice question is a multiplexer has one data input and a number of data outputs, one data output and number of data inputs, one data output, number of data inputs and number of selecting lines, one data output and number of selecting inputs. Multiplexer. So multiplexer means having output is 1 and the number of inputs to select input lines. Here we are using selecting lines also. So answer is C. Is it clear? Next one, sixth question. A multiplexer with 4-bit data selecting input is a multiplexer with 4-bit data selecting input is. 4 selection lines means once I would like to draw the symbol, it is the multiplexer. 4 data selecting lines are there means 2 to the power of 4 is equal to, we are getting 16 output lines. Okay, so means how many number of input lines are there here? 16 inputs and 1 output. Okay, once check the 4 by 1 marks, no. 8 by 1 marks, no. 16 by 1 marks. If we are having 4 selecting lines, okay, when we are giving 4 selecting lines, when we are using 4 selecting lines, if we are having 16 inputs only, we are using 4 input lines. See the answer. Okay, is it clear? 16 by 1 multiplexer. Next question. A 4-variable logic expression can be realized by using only one 4-variable logic expression. See clearly, 4-variable logical expression. See, NAND gate, no. NOR gate, no. Demultiplexer, no. 16 by 1 multiplexer. Why? Because 2 to the power of 4 is equal to 16. Okay, very good. It is clear, I think. Okay, while coming to the next, what are the previously asked question means simply what are the important questions. So in your previous question papers, you are getting the questions like this. Explain about 2 by 4 decoder. It is a long answer question. Draw the circuit diagram and explain. If they asked only the symbol, then that is a 3 marks question. And define decoder, that is a 1 mark question. Means the definitions or statements are came in examination for 1 mark like this: define multiplexer, define decoder, define demultiplexer. Draw the symbol of demultiplexer, draw the symbol of multiplexer, draw the symbol of demultiplexer, decoder. 3 marks questions. Explain the working of multiplexer, explain the working of decoder, explain the working of demultiplexer. These are the 5 marks questions, long answer questions. Okay, so this is about today's class. So which topics were discussed in today's class? Only 3 topics were discussed. All these are combinational logic circuit. Means here the output depends only on the present inputs, not on the previous input. So with this maximum our combinational logic circuits are over, except encoder. Okay, in last class we are discussed about adders, half adder, full adder, parallel adder, serial adder, 2's complement adder, subtractor. Now we are discussed about multiplexer, demultiplexer, as well as multiplexer, demultiplexer, decoder. So 7 to 8 combinational logic circuits are over. Only one combinational logic circuit is left, that is encoder. In our next class we are discussed about the circuit encoder. Okay, so once all of you remember, in your competitive examination also you are facing questions from the combinational logic circuit, like to design 4 by 1 multiplexer, how many number of selecting lines we are required? How many? 2. So to design 16 by 1 multiplexer, how many number of selecting lines are required? and at what combination of selecting lines we are selecting the bit D4. Like this, we are facing the questions in our competitive examinations. So from decoder also. So where we means if it is a 2 by 4 decoder, when the output Q3 is activated, and what is the main difference between the decoder with enable input and without enable input. If enable input is equal to 0, how the output will be produced, and if enable is equal to 1, how the output is produced. So in this way, in your competitive examination also you face the question. So especially you remember the circuit diagrams and truth tables. Why? Because if once you are able to write the truth table, then you can easily develop the logical expression. If we are able to developing the logical expression, then we are easy to write the draw the circuit diagram. Okay, so now I would like to give the conclusion about the class. Okay,